Thank you everyone for joining. Excited to give you a brief presentation about what we learned about building a data context layer. Essentially at Rig, what we're doing is data as our bread and butter. We're helping AIs and humans kind of talk to their data platforms in a better, more efficient manner. So as a quick overview of what we're going to cover today, first of all, I'd kind of like to shape the problem that we have identified and kind of explain a little bit about the reasoning. Secondly, we'll talk about what a context layer is to begin with. Like, what does that mean? How should you think about that? Then three, like, how do you build it in general? So hopefully this is a talk where we can tell you a little bit about, like the general concept, but also like what are some of the tactical tips and tricks. So we'll talk about closing the loop, like what did we learn, how to improve it, how to do better, and some open questions in terms of like things where we have a strong engineering view, and then things where we don't have a strong engineering view. And then finally kind of wrap up with some Q&A at the end. So hopefully it's meant to be kind of a useful session for you guys. Obviously at Rig, we have our own data context layer that we're providing to other businesses, but this talk should be general and should really help you design your own and think about how, irrespective of who you end up going with, if it's a home-baked version or if it's the one with us, it should give you some ways of like, how do I think about a context layer and how do I enable that? So what is the context layer really trying to solve? Without context, frequently the AI just becomes like an interrogator. So one issue that we frequently see, and I'm sure you guys have probably experienced it yourself, is whenever you're talking to an AI for the first time, you need to give it all this context, right? It's kind of annoying. Like you can ask it something like, build me a pipeline health report for this quarter. And the first thing that the AI does is like, well, where is the pipeline data? And that becomes like a big, goose chase. Like, oh yeah, then you have to think like, okay, yeah, we had it in that table, and then it was moved because we did the redesign. And they're like, okay, like it's this one, use opportunities. And then you can ask like, what defines pipeline health? And then you can say, well, I'll have to think about it, but I think last time Tom in sales mentioned it was like deals that are stuck and that haven't had activity in 14 days. And then, then the next AI asks you like, okay, what counts as activity? Emails, some notes, does that count? And you think, oh, well, I mean, I guess like emails count, notes probably shouldn't count because that's just something that we do, sometimes a few days later. So that's not really activity, and then you kind of like iterate through this process. And this is quite laborious, right? Whereas like a good coworker should probably already have all this context. So if you tell your data analyst like, hey, I want a health report on our pipeline, they're going to probably make a reasonable assumption about all of these. And so that's really the problem that the context layer is trying to solve, is basically have the AI act as a coworker, right? It's efficient. It understands the context of your business, of your database, of your IDs, of your fields, all of that, right? So we're trying to like unify that understanding the same way that a smart analyst would. So why is this a tricky problem? Well, because we have drift between the kind of what's happening, the code that's running in production, and the like final business level understanding, right? So in essence, like we can have some code running in production, and this code will, execute some SQL, some JavaScript, Python, whatever language of your choice, and that will actually execute on the actual production data and create like entries in our database or warehouse. Now, that code is obviously like, that's what kind of happens right now. Then there's the engineering understanding, right? Of like, what do engineers in our organization have in their heads? And they would like, okay, have some sort of imperfect understanding of what the code was at one point. Then there's the documentation, which is like, hopefully the engineers remember to update the documentation and hopefully it's up to date, but it's like another drift. And then there's the business level understanding of like, How do the business docs talk about it? How do people in business think about it? So that's like the effective context layer in the human sense, what it is right now. Obviously, you can see that there's already all these sources of error, and it actually is even worse than that, because if you think about it from the perspective of a fast-moving organization, there's all these changes that happen all the time. So let's imagine, for the time being, to take a page out of Ben's book. So imagine I'm Tom, and I'm just like, doing a cleanup of some database, of some processing code that basically transforms the data tables in our database. And I create a pull request, I raise it, merge it, it executes that day. And a few days later, I get a ping from Priya in marketing. And she's like, hey, by the way, Tom, I saw, you're managing this table. By the way, I stopped getting reports for this particular subsegment in marketing. Is it just me, or did I do something wrong? And you realize, actually, that's a consequence of something that you haven't thought about. So you fix it, and you kind of create another PR. A few days later, you get a on-call from an SRE who is like, oh, by the way, like, we were relying on this value being present, and now we're getting alerts. Can you fix that? So again, something that you need to escalate. A few days later, you might get a ping from Marcus from CS, who's like, oh, by the way, like, we were using this for like our diagnostics, and now our ETL fails. And again, it's another thing where you haven't considered the next order consequence. And eventually, kind of goes to Raj, who finally like finds the underlying cause and harmonizes the behavior. So that is a horror story, but it's something that I think we've all seen in some shape or form. Hopefully not every PR, not every merge request is that dramatic, but there are real issues with how we're deploying code to production, and ways in which we're not as reliable as and as thorough in reasoning about the next order consequences, right? And ideally, what would have liked to have happened in a context layer setting is, you create a PR, some smart AI looks at your context layer, looks at the PR, and says like, by the way, we think this is going to affect these dashboards for these people. This might affect this business process for those people, and it might create an issue with an AI prompt somewhere. And then you can discuss it, update the context layer, and push the PR all in one go. So that's kind of the desired state. So hopefully it's like reasonably clear that this is obviously much better. But how do we come up with a good context layer? What does that even look like? So that is a great question. And the context layer is on a high level composed of a few things. So code, some sort of processing code of like, how is this data transformed? Obviously, sample values of those data, of actual production tables, some business documents, that is usually to like align the understanding that a business person would have, or the way that your business analyst would speak about a particular metric or a particular cohort or any other definition, and obviously what that maps onto in the data warehouse. Metadata, so where does the data live, some sort of logs, some sort of usage, and then sample values and the distributions. So all of that together will form that context layer. And obviously, once you have that context layer, you should think about things like governance, who can access what, sandboxing, like how do we make sure that our AI agents don't go rogue? How do we version the context layer? How do we make sure that a business user can read about the context layer and like check their understanding, or even an engineer? And how do we make the context layer sort of self-aware or self-healing with human help? So these are all kind of open questions that we're going to get to in a second. And then obviously the way that we then use that context layer, if we're humans, we can use it through like chat. So it could be like an MCP in our favorite AI tool of choice, whether it's Claude Code, Codex, Copilot, whatever. Our AI tools would talk directly to that context layer, and our systems would talk to that context layer. That could be anything from an ETL to a workflow to a Notion page to an agent to an alert. So all of that can kind of be integrated into that context layer. So obviously there's a lot that goes into the construction of that context layer. So we've gone over a few of these areas, and ultimately what you want to have is kind of move beyond the static layer, semantic layer definition. So that's something that we've traditionally had. And obviously, like all of these kind of inputs keep changing all the time. So one of the things that is really important is that this is a continuous process. And for us, for example, we would every 24 hours, we would go through the context layer updates, look at if in the sample values we're seeing any big changes, if we're seeing any big changes in the distributions, and if we're seeing any big changes in the business docs, and kind of harmonize everything. Because what can frequently happen is that, there's some minor change in how we're processing some input, and then the distribution of like nullable values, something like that, like changes completely. And then that's something ideally most data leaders would want to have flagged to them ahead of time. So we kind of continuously try to get an accurate context. So, in the kind of pre-AI world, or the kind of the modern data stack as it was known at one point, the core kind of component of this was kind of the static semantic layer, where some human or usually teams of humans would go to their database and define for a particular field, like these are all the things that we should have kind of modeled in our warehouse or database. And there was usually a multi-week, multi-month effort of like standardizing everything, explaining everything in one place, and kind of making it easy for the business users to then consume, because then it was explicitly modeled with some understanding that was valid, at least at that point in time. Now, obviously, in the AI world, we want to move faster, and we want our agents to be able to make kind of decisions by themselves. So the AI context layer kind of now lives as a layer that our agents or our coding tools can talk to directly. And then those agents and coding tools will get information from this context layer. And once that context layer is queried, you can have a sandbox where you can try some sample values, some sample queries. And once that query is constructed, you can actually query the warehouse. So you can then have like auditing and full run a full scan of sometimes very big tables, right? So you don't have to like check, your agent doesn't always have to check against BigQuery or Redshift or the big kind of warehouse. You can model all these attempts locally and then kind of push it out. So fundamentally, we kind of create this like context layer that sits between the data warehouse and your AI coding tools or automations. We think this is like an interesting way to organize your coding system, because it kind of gives you these nice things like the sandboxing, the auditing, and the governance that we discussed. And ultimately, it is a much safer way than just giving Claude Code access to your warehouse. So what that enables us doing is essentially kind of help humans highlight all these issues. So for example, if you have like payment rates or any sort of deviations from what the norm is, the context layer can kind of flag it and help you kind of verify these issues. So as we're doing these nightly refreshes, we can say like, hey, by the way, there's a big change in the distribution of this value. Because it's modeled, we know it's important to you. Do you want to do something about this? This is something that you should be careful about. And then with the human engineer in the loop, you can kind of modify that process. So you can kind of now imagine like the usefulness and how you derive a context layer. What if you wanted to build one of your own? So your first idea might be, I want to build some sort of set of markdown files. That's very common. We've seen that in a few places where people would have like a whole bunch of markdown files, sometimes like even linked together, that would essentially create some sort of wiki. Now, the first thing that we'd advise is like, this drift is structural and accidental. Like this issue between kind of going from the production code to engineering understanding to docs to business, that drift happens everywhere all the time. And there's some fundamental irreducible context loss. So try to minimize that and try to have everything in one place, so that you can modify the code and the documentation in one go. The second lesson that we've learned is that you should probably have more than just static docs, right? So these MD files, they're going to be a snapshot. Someone kind of writes them, maybe someone updates them from time to time, even using AI perhaps. But if they're just a static files that are not refreshed at the same cadence, they will go out of date, and they will cause you issues. And so that's why, like, every time someone makes a change within our context layers, we propagate that change to the kind of next order effect. So if there's tables that are affected by a particular change, we make sure to like re-inject that context. The third lesson was kind of having a context database is extremely useful. We've seen people kind of put massive markdown files into their GitHub, and that could work for small teams or small startups, but even for them, it gets messy very quickly. And there's constant updates to those files. You don't know if that's live. Like, I understand that the desire for Git versioning is strong, but at the end of the day, having a versioning in a database is much better, and you always can be sure that you get the latest version. And then the governance and sandboxing are extremely important. We've seen people run queries that are like hundreds of dollars worth accidentally because BigQuery makes you pay by byte scanned. And if you just give Claude Code, your API keys to connect to BigQuery, your credentials, it will run those big queries. It will try to be sensible, especially if you tell it to. But we've seen so many instances in which AI agents have been running huge queries that have not been, that sometimes haven't been tested, haven't been sandboxed, sometimes haven't been, should be better audited. And all of that is something that you ideally want to think about when you're constructing your context layer, and really make those a first-class citizen. And then in terms of the behavior that we would we've learned about working with context layers to the humans, kind of moving more towards the organizational design. One thing that we would highlight to people is, don't just give the keys to an warehouse or database to your AI agents. Rather, give it to a context layer that can then intelligently manage what the agent has access to. It's much more consistent. It doesn't create all these problems. And for the humans at the other side of it is a much nicer experience, right? They connect to one centralized context layer and only then kind of talk to all their data sources. Having documents that are live and are inferred rather than authored by a particular person is extremely beneficial for fast-moving organizations, because they don't have to worry about what version was this looked at. Sometimes someone hasn't touched a particular document for ages. We're really trying to avoid that issue. So every time there's a change, if a distribution changes, that is reflected then in the docs that describe the context layer. The next lesson is more about awareness of the context layer. So you want a context layer that is self-aware, but not necessarily self-healing. We have found that data teams especially want to have a very tight control over what are the changes that get pushed out. So at Break, what we do is we kind of flag issues to the data teams, but we would not directly push anything out, we would say like, by the way, we think you might want to look at that. And that usually becomes like a start prompt for some of the data engineers to be like, okay, by the way, can you fix this in the next release? And you can just copy paste that into Claude Code or your tool of choice. But so ultimately, like, people want to have control. I don't think we're quite at the level where just having a fully self-healing context layer is feasible. Maybe maybe some are braver than us, but I think it's still nice to have that level of control. And then the last lesson is the code and data hybrid reasoning. So for a lot of the bigger kind of transformation, you want to have context that understands the data that's being used. So yeah, you want to understand both the source of that data, but also the processing code. And usually that kind of yields the best results. We are kind of more in that spectrum. We're like more data biased because we've worked for a couple of decades across the whole team in a very many situations. And in a lot of big enterprises, someone might have a way of processing a particular data set for a couple of months. Then they change that couple of months later, and then the code. If just by looking at the code, you would never figure that out. So you need to like have an understanding of what are the big releases and how they impact the actual data that appears in the distributions. So just kind of, I guess, wrapping up, fundamentally, we're big believers in driving action from context. The best starting point tends to be just figuring out what the search is. Like, how do we, first of all, surface the right information from that context? Then how do we analyze that information? That could be like semantic layer, that could be usage rules. And then thirdly, like, how do we act with that information? We make a big point of using that context layer to push out information to Slack. Here's an alert of something new that happened or a degradation in this metric. You can update, HubSpot, update your CRM. All of these things can be part of that context layer so that it's kind of managed from a central location. So one example that might be relevant to some people on the call is, for example, dbt modeling. So for those of you who use dbt, the context layer that you can construct and can be a massive accelerant for actually updating your dbt docs. So sometimes you can say, like, use the context layer MCP. I want to update the dbt docs for this table, and it will then take the lineage, it'll take the history, it'll take the table grain, the join, and kind of apply it in one location. So if you're building a context layer, you wanna think about, like, okay, how do I actually use that context layer to also speed up my engineers? Because typically, they're excited about these new tools, but you kind of want to help them. Like, how do I not just help the business side, but also how do I help the people actually writing the code? Just to kind of end my talk on some open questions. So there are a few things where you might want to challenge us perhaps, and this is something that we're kind of fully transparent about. For example, is the versioning that context layer should have better in a database, or kind of with some Git kind of sprinkling on top? Like, is there a better way to manage the context files and the context layer within Git itself? Because obviously that gives you nice diffs. That could be useful, but we found that it's much easier to just kind of keep it in a database, and kind of, rather than having all these constant reads and writes as the data changes. The code integration. So at the moment, we're very data centric. So we look at very heavily what the data is, what's the distribution. We don't always try to reason from the code itself, from the ETL code or other processing code, what the sample of possible values is. We could do that, but we found typically better to just look at the data. And maybe there's like a better hybrid approach where you can actually get the best of both worlds. Third is kind of like, what are the bottlenecks that slow down teams throughout the organization and moving faster with their AI tools? So context is certainly helpful for a lot of data analysts, data engineers, but is it sufficient? There's other bottlenecks that happen very frequently, especially in large orgs, and we want to make sure that the context layer serves the business users, the technical users, but also the organization as a whole. And then the self-healing element, I think, some people, I think especially in like the YC Silicon Valley types, love to like go all in and kind of let their agents autonomously rip on their code bases. You can do that in theory. I think we're like a little concerned about like the lack of control that the human might have, because you're kind of constantly changing the ground from underneath you. But it is, these systems are getting pretty good. So maybe at one point it will be feasible. And then, of course, like the alerting mechanisms, like what's a good way to not overwhelm humans, but at the same time, like give them an interesting enough of an interface to like give them a broad sense of like the types of changes that are happening every day within their context layer. So with that said, I'd love to open up to the questions. I'll leave you with the idea that like context is not just documentation. It is like at this point part of your infrastructure, because it will go into your prompt, it will go into your AI coding tools. So you definitely want something that's live, something that's observable, something that's governed, and something that understands both in the code and the data. So that's it for me.